Hello everyone, in this video tutorial I'm going to give another example of how to use the effect size calculator within our Excel spreadsheet. For this example I'm going to be using mean and standard errors as a statistic and design 2, which is post-test data reported only for an experimental group and a control group without any pre-test data reported. So if you look in the description of this video, as we mentioned in previous videos, you can download this Excel file. This will be our calculator file and where you'll build your database. And there's also going to be a link for this study that we're going to use as our example. It's Lisa Eaton, and she did a study in 2011, and here's the title. You'll be able to download that for free online. Now if you open up the calculator, if you don't have this tab already, please create it, Effect Size Calculations tab. This is where you're going to create your database of effect sizes that you're going to accumulate. So you're going to create this tab, and you're going to use that tab and the calculator tab to calculate your effect sizes. Once you have this tab, you're going to highlight these first 4 rows from the calculator tab to copy and paste the headings of each column. And you're just going to copy and paste them right into here. Zoom out just so you can see everything. So now you have everything set up how you're going to want it. And then what we're going to do is we're going to actually go through this example. So we're going to go and we're going to open the study up. And like previous examples, I'm going to go straight to the results to give you a general idea of how the study was run. So in this study, there was 2 groups, an intervention and a control group, clearly reported here, and there was 2 follow-ups, a 1-month follow-up and a 3-month follow-up. So you're going to have to examine the table bit, and this is a perfect example of why you need to look closely at tables and look closely at what's reported in the study. If you look down here at the bottom of the table, I'm going to highlight it. It says note adjusted means are presented. So this study actually reports 1-month and 3-month data for all of these outcomes for intervention group and control group, and it does not report the pretest data. But actually in this particular study they did collect pretest data, they just didn't report it in the table. So instead of reporting it, they adjusted their means to control for the baseline data. So these follow-up means and standard errors are actually controlling for the baseline data. So if we look in the results section, in our data analysis section is usually where it's going to tell you if there's been controlling for any covariables. So since it's been noted in the table, we can go back in the text and look. And as you can see right here is where it says it. We treated baseline behavioral data as covariates, and we entered condition time and their interaction as model effects. So it's basically saying what's being controlled here is the baseline data. So we're going to show you how to input that and note that when you report your effect sizes in the calculator. So for this example, we're going to compare the intervention to the control group on economy self-efficacy. And first we're going to do the 1-month follow-up, and then we're going to do the 3-month follow-up. So we're going to minimize here for a minute, open up this, and like I said, we're going to want to do 2 things when we look at a study. We're going to want to recognize what's the statistics being reported and what is the design being reported. So although this study used pretest data or collected pretest data, it's actually reporting the post-test data only and controlling. So although it may seem like it's design 1, which is using pre and post-test data for experimental and control group, we're actually going to use design 2, post-test data only for the experimental control group, because that's what's reported here, and we're going to indicate within these control variable columns that they're controlling for baseline. So it's reporting the post-test data only, although it's even controlling for baseline. So since it's post-test data only, we're going to identify that as design 2, and then we're going to figure out what is the statistic. So in this case, the statistic is means and standard errors. It's indicated here and indicated in the headings. So we're going to copy this row and we're going to paste here. As I've said, we're pulling calculators from here. We're pulling the effect size calculators from here. You're never going to actually enter anything in this worksheet. All you're going to enter is things in this worksheet. So you're pulling what you need from here based on the study you're using and copying it into here to build a collection of these rows, a collection of these statistics and designs and studies, so you can build an effect size database. So to briefly go through these columns again, this first column is going to look at the manuscript ID. So this is the arbitrary identifier that we're using to identify our study. Like I've said, you may have a different one than we are using here. You may have your own system for classifying your studies. This is an arbitrary identifier that we happen to use. So in this case, it's EAT002, as given in the heading of the PDF. And you're going to want to put the reference in this column. So a general abbreviated reference for the study. So Eaton Cherry et al. 2011 is the study in this case. The stats is mean and standard error. The design is design 2. The subgroup is going to be the groups you're comparing. So we're going to be comparing the intervention to the control group. You don't have to enter this because it's a given that you're comparing an intervention to a control group. Usually you type what groups you're comparing when there's multiple groups, so you have to identify which ones are being compared in that row. But just for demonstration purposes, we're going to put intervention versus control. So first we're going to do this 1 month follow-up for condom use cell efficacy. So like I've said in other videos, this follow-up is going to indicate what number of delayed follow-up that we're using. So we start with 1 at the first delayed follow-up, 2 at the second, 3 at the third delayed follow-up, 4 at the fourth. So looking at what's being reported here, there's a 1 month follow-up and a 3 month follow-up. So 1 month is going to be the first delayed follow-up, and 3 months is going to be the second delayed follow-up. So we're starting with the 1 month follow-up. So we're going to put 1 as first delayed follow-up, and we're going to put 4-week follow-up here. This column indicates the number of weeks followed up. 1 month is equivalent to about 4 weeks. We equate each month to approximately 4 weeks to simplify calculating the effect sizes in weeks. So whatever number of months the follow-up is, you're going to multiply by 4 to get the number of weeks. Then we're looking at our measure as condom use self-efficacy. We're going to enter that here. Outcome, like I've said more in depth in other videos, that this is just a way to categorize your effect sizes. You're going to decide the way you're going to group them depending on what studies you're using and what outcomes you're analyzing and how you want to group your data. So we're going to actually just cover this in another video. For now, we're going to leave this blank because it's not important for our purposes. So these two columns are important. Typically, means and standard deviations, means and standard errors, what's typically considered raw data is not controlled for. In some instances it is, which is why it's important to both read the text and analyze the table. In this case, as we said, it's adjusted means, and it's adjusted for baseline as noted in the text. So what we're going to do here is in this column, control for covariables is a simple yes or no. In this case, it's a yes, we are controlling. And this column, list for covariables, it actually wants us to say what variables are you controlling for, so we're going to put baseline. Derivation note is going to be what page we got the data from and what table or the text. So seeing down here, page 543, and this is table 2, so we're going to put that in here. Now looking quickly here, this will help you understand kind of how the format of the Excel sheet works. And once again, this has been gone over in other videos if you'd like a more in-depth explanation, but these 6 cells are considered experimental group data, and these 6 cells are considered control group data, and they're indicated here by these headings. These 3 are for pre-test experimental group data. These three columns are for post-test experimental group data. These three are for pre-test of control group data and post-test of control group data for these three columns. Now, if you notice, these yellow boxes, these yellow cells are only the ones we're going to be entering data for. And notice there's no pre-test cells highlighted, and that's a reflection of us using design 2. So design 2 is post-test data only for experimental control. So since we're not using any pre-test data, we're obviously not going to be entering anything into the pre-test cells. So we're only going to be using these cells for the experimental group and these cells for the control group to enter data. So looking here, so we can look at both. Economy self-efficacy 1 month intervention group. So we're going to go here. We're going to see the 5.49 to 0.08 is the mean standard error. And looking at the control group, it's 5.28 and 0.12. Now, as you can see, there's no sample sizes actually reported here. So in this instance, we're going to actually have to look through the study to find out what the sample sizes we're going to use are. In this instance, there's a flow chart. Usually, if the data is not reported in the table, your next move is going to be to check the text and the flow chart for what data to use. Sometimes the text will report specific sample sizes that are used. So in this instance, the flow chart is telling us that 75 people were randomized to the control group at baseline, 74 to the intervention group at baseline. 88% of those were assessed at 1 month for the control group, and 77% at the 3 month, and 87% of the 1 month for the intervention, and 81% of the 3 month for the intervention. So these percentages pertain to the baseline number. So we're going to click back over here, and we're looking at the 1 month data. So this is the experimental group. So this is this row right here. So these numbers are going to tell you the experimental group data. So we're going to actually calculate the sample size at 1 month. So we're going to multiply 74 times 0.87, which is the percentage of people followed up for the 1 month. And for the control, it's going to be 75 times 0.88, 88% of people who were followed up for the control group. I tend to leave my numbers when they're calculated like this as decimals, just because that's how we calculated them. Some people round them. Someone would round this to 64. Whichever way you prefer to do it is fine, as long as you're consistent throughout all your calculations. So maximizing the screen. This is the effect size for the experimental pre-post and the effect size for the control pre-post. Obviously these are empty because there's no pre-post change, there's no pre-post data for each of these, there's only post-test. So these are blank. So in this instance, we're actually using, as you can see highlighted here as we highlight the equation, we're using the post-test data from the experimental and the control and comparing them. So this number is positive, which is indicating higher values in the experimental group than the control group. So this is a positive thing to show that condom use self-efficacy actually improved compared to the control group and the experimental group. Now we're going to input the 3 month follow-up data. So we're going to scroll back down to our table. And we're using this data right here. And since we're using the same data, we're going to use design 2 and design 2 and means and standard errors again. Click back over here to our database. The manuscript ID is going to be the same because it's the same study, as well as the reference since it's the same study. This data is the same as it copies over from the calculator you chose. It's still the intervention versus the control group. So we're going to copy that within the subgroup column. The follow-up is now no longer the first follow-up at the 4-week or 1 month. Now we're looking over here, we're looking at the 3-month. So this is going to be the second delayed follow-up. And 3 months, 3 times 4 is 12 weeks. So 12-week follow-up. Looking at the measure, we're using the same measure, so you can copy and paste the count of use self-efficacy. Outcome, like I said, we're going to leave blank. We'll explain that in another video. Once again, this measure is controlling for baseline. So since it's controlling for the baseline data for this variable, we're copying and pasting that. Show once again that it's controlling for that. It's coming from the same table, so we can copy and paste this. Then we're going to minimize again, and we're going to enter the experimental and control post-test data. So 5.62 and 0.08 for the experimental. 5.25 and 0.11 for the control. And to get our sample sizes, once again, we're going to scroll back up, and we're going to estimate from here. Intervention group, 81% of the 74 attended the 3-month follow-up. So 74 times 0.81 times the 81%. It's going to give us about 60 people. And 75 for the control times 77% assessed at 3-month. So times 0.77. It's going to give us approximately 58 people. And now you have that row complete. So looking at the effect size, another good indication that the experimental was more effective than the control when it came to economy use self-efficacy over time. And you can say that's over time because it's actually controlling for the baseline. If it wasn't controlling for the baseline, it would just be strictly a post-test comparison. But it's actually taking the baseline into account when it's calculating these means and standard deviations. So you can see the change over time as a control for these variables. And that's going to conclude this video, and you can click through our other videos to see other examples for other designs and other statistics.